roadmap to career in VLSI. So in this webinar, we'll be concentrating on how the VLSI industry is working and how to get into the VLSI industry. That is the more important topic which we have all gathered to discuss this point. So, and also we'll be giving some tips and tricks like how you can get into the VLSI industry. And I think almost everybody of you, if not everybody, most of you, those who are present here, I think you're all searching for a job. And some of you might have not yet graduated from college. Some of you might be belonging to different years. Okay. So for anyone, regardless whether you have graduated or not graduated, we can discuss and we can help you. I think we can help you how you can land a job in the VLSI industry. Okay. So on that note, let's start the presentation. All right. So my window is visible, right?
Yes, sir.
Okay. Thanks. So let's start. So coming to our agenda. So these are some of the topics we are going to discuss. So we can start from the theoretical points. So theoretically, what is the VLSI and how the VLSI industry is working, and what is the position of India in this VLSI industry with respect to the world and with respect to the normal case. All right, and what is the current situation and how it is expected to grow in the future. So even though we can't exactly forecast what is going to happen, but still we can see some developments which have happened in the recent years. All right, and what are the major big players who are currently dominating in the VLSI system, and how to break to the system. So I think everybody's dream job is to get into a Taiwan product company, right? So how we can conceptualize this goal and how we can achieve this. So those things also we can see. And regarding some ESI ASIC design flow, how the ASIC design flow is done. So those things we can see. And what about the job profiles, the various job profiles that we are going to discuss. Okay. And an important point to note is that we are not going to discuss regarding all the job profiles. The agenda here, like the thing here, it is restricted to mainly the design and the verification. Okay. So for those of you who are not aware of this thing, so we are going to exclusively focus on a select certain fields in the VLSI in the front end. Okay, so VLSI is already divided into front end and the back end. Okay, so this is just a little bit of information right now I'm giving. You don't need to worry about it. While we are going to discuss about that point, we will discuss that time a little bit more. Right now, you can just have this information in your mind. Okay, so in the front end, we have some various job profile. Actually, VLSI is very broad. Okay, so it is very broad and it is very vast. So in that, we will be focusing mostly regarding the design and verification, how you can go through this field. Okay, so and also regarding the misconceptions, like what are the misconceptions that people have in their mind regarding the VLSI domain. All right, and the roadmap regarding how to start a career in the VLSI. Okay, so what is the roadmap and the steps you can take from today, starting from today, how we are going to start it. Those things also we can say it. All right, and what are the DV topics you need in order to crack the interviews? You need to prepare on certain topics. Okay, so you need to have some solid fundamentals on a solid background. Okay, on a solid base regarding certain topics in order to crack into a DV. So even though you may not going into direct Taiwan product company, so it is actually impossible. So unless if you are from IITs or NITs, those kind of colleges, it is very impossible for us to directly break into there. Okay, so even though it is not possible today, we are going to enter into a Tier 2 or a Tier 3 company. So even then, we need to have some solid fundamentals, and the companies which are going to attend there for interviews, they will make sure that we are thorough in all the topics. Then only they are going to let us in. Okay, so this is the agenda right now, and moving on. So we can start from the very basic. So what is the VLSI? Okay, in a simple one-word definition, the word VLSI is nothing but very large scale integration. So you're going to integrate some number of transistors in a single chip. Okay, so these transistors, as you know, it is very minute. So you're going to integrate this minute set of transistors in a single chip. Even the chip is also going to be a very little space. It is going to consume a little space. So in this tiny space, you're going to integrate that much of transistors in a single area. So that is our VLSI. Okay, so this field is very important, and currently in this modern era, it is very important. And where the application, where it is used, this thing is used in everywhere. Okay, this thing is used literally everywhere. So currently, even in the phones or in the laptops or even in the computers, wherever you are using this thing, there VLSI is certainly used. Okay, so in that case, let's see a little bit of basic example. Okay, so I think people of various backgrounds are here, but I will keep this a little bit short. Okay, so we are not going to deep dive into the theoreticals. Okay, so I will try to as much as keep it short and brief. Okay, but bear me with a little. Okay, I will try to discuss some theory things also for you so that you gain a little bit of understanding. Okay, so if some first years are still here, those who have not discussed the subject of digital logic design and digital electronics. So if these subjects have not been taught to you as of now, so for them, I will try to introduce this subject. So in the VLSI, okay, so you have a, let's take an simple example. Okay, so in previous days, people used a thing like let's say a typewriter. Okay, people are using a typewriter. So this typewriter, as you know, is a mechanical thing, right? So it is a mechanical thing. So you're going to press a button, and then this mechanical thing with there is no digital involved. Okay, it is completely a mechanical physical part. So it is completely going to be work based on those things. Okay, so the metal is going to imprint some ink in the paper, and then it is going to work based on that. Okay, so this is a mechanical thing. So coming to our modern time, right now we have the keyboard. This keyboard is not a mechanical thing, right? Because we are going to press a button, and then it is going to send electric signal, and this electric signal is going to be processed by your CPU, and then it is going to convert it into a digital information, and then it is going to display in the what? It is going to display in your screen, right? So this is how it is going to work. So this is your simple bit of example. But right now, if you compare this mechanical thing and the actual like electric thing, there is a lot of differences. There is a huge leap in between them. So how this thing and this thing is different is nothing but with the help of the VLSI. Okay, the main thing this digital thing is going to use is that it is going to use a CPU. Is mostly importantly, more importantly, it is going to use a kind of a memory element. Why this memory element is required in modern cases? Because in almost everything you need to employ a memory element. So whatever information you're going to working on, this electrical thing, digital thing is going to do what? It is going to store. Okay, so if you want to employ a memory thing, so how you are going to achieve this purpose of storing this thing? How it is made possible? So you are going to use a for starters, we will use the flip flop, right? The flip flop is what? It is nothing but it's a memory storage. All right. So this is coming in the topics of the digital electronics. Okay. So for those of you who still don't know, it is nothing but it's a memory storage device. It is going to store the data. Okay. So it is going to just store a single bit of data. But if you are going to store in large volumes, you will also convert into a bigger memory structure. All right. So this is how it is going to work. So this is the case. All right. So this is the little bit of analogy how this VLSI is going to be evolved. All right. So this is a simple example. So firstly, how this transistors have evolved over the ages. Okay. So from the old, we have discussed. I think we have discussed this typewriter example. But if we take on the world level, so I think you are all familiar with this. the history of computers, how the computers have evolved and how they were developed. Okay, so in the pre-electronic era, okay, if you want to do all this logical operation thing, so you have the logical gates and all, right? So if you want to implement these gates, how are you going to implement it? Okay, so before this digital electronics came into picture, what we had at hand was this mechanical thing. Okay, so we had some mechanical relays, we have electromagnetic relays, so those things were there. Okay, so after this thing, then only we had this vacuum tubes which were used in the earliest computers. So you know this part, all right? So those who are acquainted with the history of computers know this part. We had the vacuum tubes which were used in the earliest computers, and then the transistor came into the picture. So this transistor was a very good invention. With this transistor, we had some concepts like BJT. Okay, so the BJT is nothing but the bipolar junction transistor. Okay, so like I told, we are not going to go very theoretically deep. So bipolar junction transistor is a different thing. So it changed everything how every computers worked. So using this BJTs,
Excuse me,
you
sir.
you can implement.
Sorry for interrupting, but most of them are complaining that the PPT is not visible. Can you see by sharing it again?
Okay, just a second. Okay, is it visible right now?
Participants, if it's visible, please give a thumbs up. If not, just put it in the chat.
So for you, it is visible, right?
Yes, sir, it is visible. You can continue. Thank you.
Okay, fine. Okay. So as I was saying, I was discussing regarding these transistors. So we had this BJTs, right? So this BJTs was a very good invention. So it changed the whole electronics industry, right? So from this BJTs, then we had the next IC. Okay, this IC was also developed, and I just want to side note, we regarding these transistors and these ICs and all, we had this germanium based elements. Okay, so the metallurgy, the elements which were used in regarding this construction was the germanium. Okay, so germanium was there. Currently, all the chips which we are using, like which we are constructing, we are used it with the help of the silicon element. So before silicon, germanium came, like germanium was used. Then we had the silicon. Okay, and then after the germanium, the transition happened from the germanium to silicon. So that one they have termed it as the silicon revolution. Okay, and from this, okay. So from here we had the MOSFET technology. Okay, so this MOSFET was another good invention. So it is nothing but the metal oxide semiconductor field effect transistor. Okay, so from here everything got very much like the size got drastically reduced. Okay, the size were very reduced. So starting from the vacuum tubes, right now it got very much reduced. All right, from here we got the CMOS technology, nothing but the complementary MOS technology. So using these transistors right now, we started building all those kits. Okay, so everything which you are going to build using the processor and all, so it is all composed of gates at the minute level. Am I right? So gates are used everywhere. So whatever thing which we are taking, even if it is a big thing, it can always be broken down into a smaller entity. So at the most minute level entity, if you zoom in and if you see it, okay, so we can't zoom in, but I'm just using that word metaphorically. So if you zoom in and see it, everything is composed of gates. All right. So these gates we are constructing with the help of those transistors. Okay, and we had the CMOS technology, those things and all. It made everything a lot more easier. All right. So from here, all the revolution came place. We started like the first Intel 4004 microprocessor came, and it was everything. the beginning of the microelectronics. Okay, so this is a very great transition. So the number of transistors that are employed in a single chip, it got increased. Okay, so from one or two, we had 2,300 transistors. Okay, and then we had the VLSI era. Okay, the VLSI era is nothing but we had the EDA tools. So this EDA tools is nothing but these are kind of the software tools where you are going to build all those things. Okay, so why these EDA tools are employed, I will come to that point later, but this is just like an introduction kind of thing. Okay, then after that you had the transition from thousands to where to millions, and even you have billions also right now. So today's example, so if you take a recent chip which was developed by Nvidia, which was developed recently in 2023. So almost 80 billion transistors were used in this developing this chip. So it really was a game changer. So how much small we like, how much big we started, and how much small we have evolved. So it is a really great thing which we have seen the transition in our VLSI. Okay, so all these things have been covered. So I hope you are clear with all these things. This is the little bit of evolution. So this is a Moore's law. So I don't need to worry about this law thing and all. So I don't want to sound this like a physics class, but this is just to know that how the transistor count is doubling every 1 or 2 years. How the transistor count is doubling. So from the like previously I've told like what just one transistors were there, like a number of transistors were there. From a handful we have now we are in the billion space, right? So how they were evolved. So in this doubling, they are just used a law developed by a guy from Intel. Okay, so even though this law is not applicable right now, but still this law is used in a historical context. So it was true to a certain extent. Okay, so how the number of transistors is doubling each and every time period. Okay, from the past. All right. So let's see about the hierarchy. The hierarchy is nothing but I've told you right how the chip is constructed. So if you zoom in and if you go on inside deep, so at the most tiniest level you have the gates. Okay. So the why this transistor thing is given at the last is the reason is the thing is nothing but all the gates it is being constructed with the help of the transistors. Okay, so while diagrammatically while we are drawing something in the digital logic class we will draw everything in the gate level. Okay, but while we are constructing those chips we will be using the transistors. Okay, these transistors can be arranged and they can be used to work as a gates. Okay, so that is why your transistors and gates they are kind of a little bit of interlinked. Okay, so they're a bit of closely interlinked and they're used interchangeably. All right, so that is your transistor and your gates, and a large number of gates are used, and in turn this constitute a single circuit. Okay, your circuit or a block, and then you are going to employ a large number of circuits. So here you have a lot of different things. Okay, and for example, you are going to have a thing like you're going to have a memory, so you're going to have a arithmetic logic unit, so you're going to have a control unit. So like that, it is going to have a lot of different things. Okay, so all these blocks, all these circuits, in turn, they are going to constitute one complete architecture. Okay, so this architecture is being employed right now in a single chip. So this many things are being employed in the chip. Okay, so you are clear with all this thing. So this is the thing in your processor and how it is constructed and how everything is working. Okay, so I think I have made it in a sufficient way of explanation to make you understand everything. Okay, so right now we shall discuss about India's VLSI journey. Okay, so in India's VLSI journey, how where it is standing with respect to that. Okay, so till now what we have seen regarding this vacuum tube things starting from the transistors and the BJT. So all these things it have been discovered in the US. Okay, so everything was done in the US. So that is why US is the powerhouse. But we don't want to go there. Right now we are just going to see about India's place in the VLSI industry. So where it is standing right now. So this India's journey it started from the 1960s though it was not that much successful, but it was just a starting. Okay, so it started a PSU, and it started establishing some producing some chips. Okay, it started producing some chips, though it is not for the consumer purpose. It is for mostly for the defense and space, those kind of things. But it wasn't that much successful. So some kind of accident happened, and the fab got ultimately destroyed. Okay, and then in the 2000s, so the 2000s, just a little bit of history thing. So in the 1991, India started to relax its laws. So it started to employ some private funds from all over the world. Okay, so it needed to attract some foreign investors into the country. So it privatized some of those industries. Okay, some of the industries which are present. So before 1991, every industries, like not every, like most of the industries were like government owned entities. But after that, things started changing. So India started economically, it started economically getting better, and everything was getting raised. The reason was because it started attracting foreign investors. Okay, so that is the reason why the IT market was so much large. Okay, then came VLSI. Okay, VLSI was a little bit late into the picture compared to the IT. Okay, so what is the little bit of differences between this IT industry and the VLSI industry? I will come to this point right now. But regarding, let's say, see regarding the VLSI, how the VLSI thing came. So IT, it predates a little bit earlier compared to the VLSI. VLSI, as I've told, VLSI came a little bit of earlier, sorry, late into the picture. So it came after 2000s. Okay. So how means, like some multinational companies, like those big companies which are dominating everywhere in the worldwide, those companies, they started coming to the country, and they started setting up offices and centers everywhere. Okay, so these Indian IT firms, so like what all bigger IT MNCs are there, like Wipro, HCL, TCS, Tech Mahindra. So these kind of companies, they started providing VLSI design services. Okay, so this is how India started its journey from the 2000s. Okay, so currently, right now, India is right now, it has a lot of uh, it is offering a lot of services. Okay, so it is offering a large number of percentage in the world semiconductor design workforce. Okay, so note the point, I didn't say VLSI, I just said design workforce. Okay, design workforce is a particular field inside the VLSI. If it is the whole VLSI, then that is a whole other different story. Okay, because I didn't use the word VLSI, it is just in the VLSI we have design, right, like I've said. So in this design case, India is a very good, is very much leading in this subsidiary. It is making very good progress in that. Okay, and also India is trying to set its footprint on the other domains that is available in the VLSI. Okay, so currently the semiconductor manufacturing. So this is the place where India is lacking right now. Okay, so there is not a significant presence in the semiconductor manufacturing. Okay, so there are no fabs in the country. Okay, fabs in the sense like a fab which is most not worth noting of producing massive chips. So those kind of fabs are not available in the country. Okay, the reason is because these fabs, these foundries are nothing but these are the actual places where the chips will be manufactured. Okay, so these are the actual places where the chip will be manufactured. So those things, it is not at all there. Okay, if we want to establish such a fab in the country, it is going to it is going to require a lot of capital. Okay, it is going to require a lot of capital. It is going to require a lot of investment. It needs time, energy, money. It needs everything. Okay, and also another one thing which the fab needs is it requires massive tons and tons of water. Okay, so it needs a lot of water to keep a fab running and to produce the chips. So that is why even if you leave India and if you take at the whole world level, only a few companies and a few fabs are existing even in the world. Okay, so there are only right now a few fabs, like a few places where the chips are produced. Okay, Okay, so one of such places where these chips are produced is I think you know this. It is from Taiwan. Okay, so from Taiwan, most of the chips are being produced, and from these chips only every other company is taking. For example, from Apple or from Samsung, from whatever other companies, they are going to take the chips which is produced from Taiwan. Okay, so this is the semiconductor manufacturing thing. Okay, so regarding the ecosystem, I will come to that point later. Okay, so now current topic. So this is regarding the manufacturing thing and those things. This is the status of India right now. Okay, so now let's leave these things aside, and now let's see what is regarding the academic thing. So regarding the academic foundation, the academic knowledge, which is regarding the VLSI, it is good in the IITs. Okay, so in the IITs and the IIS, there it is much better. But a little bit of a side note, but in the other colleges in our country, especially saying regarding this tier 3 colleges, in those places, actually the curriculum is very bit outdated. Okay, so apart from that, regarding our academic research which has been done in the IITs and IICs, there it is very much better compared to there. Okay, so this is just a side note. But apart from that, here again we need to go from one step to another step. Nothing but the transition from this academic knowledge which we have at present in our hands to the directly to the workforce, to the company workforce. There they are expecting a whole set of new things from us. So there we are not going to they are not going to expect us with this knowledge which we have gained in our colleges. Okay. So I think you have learned the subject VLSI in your college. So those who have this, I think you have studied how the chips are done, like not the chips, like how the PMOS is molded, how it is done. So a lot of chemical process, how the fabrication is done. So all the metallurgical process that is happening. So all these things, I think you have seen. So we don't need all this type of knowledges to enter into the workforce. So the knowledge which they are expecting from the company is totally different. So they are not expecting us, to write regarding CMOS or write regarding PMOS or how the gate is constructed using BJTs and how the gate is constructed using the CMOS technology. So those type of knowledge they are not expecting us when we are going to join the workforce. Of course, they may expect some questions of this sort when we are joining a relevant domain. But if we are going to join which domain or not, like for example, if I'm going to join the front end, there it is no use that I'm going to study regarding the back end knowledge, right? So we need to know what work we are going to do. For that, first we need to know what knowledge it actually comprises. So all these things we need to be particularly thorough of. All right. So regarding the next point, as I've told you, why the VLSI is not as big as the IT industry. So what difference is there between this VLSI and this IT industry? The thing is that I told you, like this fab thing, in order for you to run and maintain a fab, the fab is nothing but a foundry where you're going to, manufacture the chips. They're consisting, like if you want to set up it, it is going to cost a lot of money. Okay, it is going to even cost a lot of money, and there are significant losses involved in setting up also. Like if any one thing goes wrong, and if you're not getting the expected result, it is going to result in a severe loss. So this is not the case in the IT. Okay, so you're going to write the software. It doesn't involve that much of capital and the investment. All right. So IT, you can just simply write the software and you can just outsource to your companies, like to the clients who are there, to the offshore developmental centers, and they are going to supply it. Okay. It is not that much of big thing. And even if it goes wrong also, even in that case also, if something goes wrong, there is not that much significant loss compared to the VLSI in IT. All right. Because the thing is, their money is not that much involved. Okay, so unless you may pay some money to the guys who are working on this codes, but apart from that, there is not a, what can we say, a significant capital investment. So that is why here the major disadvantage is respect to the money. So it needs a lot of money in this kind of thing. And also another one thing is that the ecosystem is very big. Okay, so not even in India compared to the whole VLSI industry, the ecosystem is totally different. Okay, the ecosystem is totally different. Okay, so if we produce a chip, if we produce something, we can't just directly sell in the market. Okay, so it is totally different with respect to the software. So if I'm going to produce a processor, let's say I'm going to produce a processor, and I'm going to sell this processor to market. So it's not like people are just going to come and see this processor and they're going to buy it. It doesn't work like that. We're going to make a partnership with another kind of companies, and then those companies are going to employ your processor in their computer. Okay, so this is how it is going to work. Okay. So, for example, if there is my phone and if there is my computer, so there it is not absolutely mandatory that I'm just going to use the processor which has been produced by my own company. You get it? Okay, I'm going to get the processor from outside. Okay, I'm going to employ the processor from outside, and I'm going to produce from other company, and then I'm going to take and insert in my own computer. Okay, so it is like a deal. Okay, this is how it is going to work. So this is how the market is going to work. So everything is totally interconnected. Okay, so each one is dependent upon the other one. So it's not like I can survive on my own. Okay, every company is little bit of dependent upon the other company. Okay, so in order to give a little bit of example, I think you all know the company Nvidia, and right now Nvidia is the topmost company right now in the market. So they have right now their shares are worth more than trillions of dollars. Okay, and that too regarding this uh, famous GPUs and everything, they have totally reinvented the whole industry itself due to their innovation. So in this Nvidia, their company doesn't have a fab in the sense they doesn't have a what can I say, a particular a particular procedure to produce a chips. Okay, so they are not producing their own chips, they are not manufacturing their own chips. So those chips they are getting from another companies. Okay, so from companies like TSMC. So TSMC is the company which is there in Taiwan. So they are producing all the chips. Okay, so from they are going to make a kind of a partnership deal, and it is going to not just with TMC, they are going to have a partnership with a number of companies. So all these companies is going to depend upon one another. Okay, so so from one company I'm going to get the processor, in another company I'm going to get from this, and another company I'm going to get that. So this is how it is going to work. Okay, so that is how this thing is working. And also with respect to India, this particular ecosystem is very weak. Okay, we totally don't have this manufacturing base in our country, as well as this market is not there for India with respect to this manufacturing thing. Okay, so that's the thing. But this thing, all these constraints is not present with respect to the IT industry. Okay, IT industry, there is always market, and also the labor is very cheap with respect to VLSI. Okay, so people can always come and buy the services here in India for cheaper amount compared to the worldwide. So this is why the IT is very good compared to the VLSI. Okay, so all these are the current situation. So I just discussed how the VLSI market is working with respect to the broader context, in the global context, how all the companies and how all the supply system chain is working. Okay, so we will categorize it more, and how it is working we will see it. Okay, so okay, so here in this slide, so whatever points I have told you before, they have mentioned it. One second. Okay, so how the Indian startups are working. So right now, a lot of startups are happening to come in India. Okay, so it is going to start to come in India, particularly the hub is right now the hub of VLS in India is nothing but Bangalore, and Hyderabad is closely following Bangalore, and after Bangalore and Hyderabad places from North India is rising because of the significant investment that have been made in the recent years. particularly in Gujarat actually. Okay, and after Gujarat we have cities like Chennai also. So all these places, it is starting to rise. Okay, so like I've mentioned that it excels only in the design services, not in the manufacturing. Okay, so we can expect a lot of growth in India in this side. Okay, so particularly in due to the rise of artificial technology and all artificial intelligence technology, so we are expecting that the IT industry is going to shrink little by little, day by day. Okay, but those type of things we are optimistic that it is not going to happen in VLSI. Though even if some kind of if some kind of downscaling is happening in VLSI, it is not going to significantly impact the VLSI industry compared to the IT industry. And also in the recent years, people are gaining a lot of awareness, and they are getting to know that such industry is there, and they are offering lucrative pay with respect to the with respect to the all the companies and all, and the pay is very significantly good compared to the IT also, and that is why people are right now they are even people those who are already joined the IT industry, those who have worked for let's say for 3 or 4 years, I have seen that my own eyes itself. They have worked for some number of years, and after that they have came to realize that all the worked years is a waste of potential, and they are leaving those industry and they are switching to VLSI industry, even though it takes a lot of effort at the beginning. Okay, at the beginning the VLSI industry to stay afloat. Okay, so this is some of the things with respect to the VLSI and IT industry. And right now we shall let's see about the ecosystem how the semiconductor industry is having. Okay, so this I told you about the fab, right? This fab is nothing but the foundry, and apart from that, what other different types of categorization of companies are there? So, for instance, we have the chip design house, and then we have the IP design house, and then we have the EDA tool manufacturer. Okay, and then we have the post silicon validation companies, and we have the service companies also. Okay, so all these different type of companies are there, and as you can see in the arrow mark itself, so all these companies are having a kind of interlinked web between them. Okay, so each of these companies are doing what, like they are doing their own roles, but they are not doing it independently. Okay, so each one is depending upon the other one. So this is the interlinked web in the semiconductor ecosystem. So in that one, so we have seen about the fabs. So how the fab is going to do and what is the role of the fab. So this one we have already seen it. Okay, no need to see it again. Then we have the IP design house. The IP design house is nothing but it is like a, let's say it is going to, IP is nothing but intellectual property. So here it is going to develop all the IP blocks. Okay, so this IP blocks is nothing but, for example, let's say I need some memory kind of thing. Okay, for instance, I said at the beginning, right? We need a memory. So some companies they don't necessarily develop their own memory. Okay, so they will borrow it from some other company. So in this case also, they are going to get the memory IP from another company and they will use in their own product. Okay, they will use in their product. So, and also remember one thing. So this IP is not a actual physical thing. Okay, so it is a software thing. Okay, IP is a software thing. Okay, and after that you also have the chip design houses. Okay, chip design houses is nothing but they will make the SoC. Okay, so SoC is nothing but system on chip. They will use the SoC and then they will develop those things like whatever digital code you have used and you have developed those digital things. You will convert it into the like the bitstream file. Okay, so you are going to develop into the bitstream file. More on this ASIC design flow later. Just bear with me for a while. Okay, so this is your uh, design house. Okay, and then after that you have the EDA company. So this EDA companies is going to give this the tool where you can write all these codes. Okay, so here for in the front end in the design part, you're going to use the tool to develop codes. Okay, so I just want to, I think I should have told this before itself. So in the VLSI, like let's go back, let's rewind a little bit back. You have the circuits, right? We have the gates. Okay, so let's take a simple gate like a half adder or a full adder. So I hope everyone present here knows what is a half adder and a full adder. If you don't know, for starters, it is a circuit where you are going to do the addition. Okay, so it is going to consist of XOR gate and an AND gate. Okay, so you know this part. Okay, so now this gate is drawn. Okay, in a diagrammatic way, if you ask someone to draw a gate, you're going to draw it. Okay, so this something is, you know it. Okay, in the older times, you had a simulation kind of tools. Okay, you can simulate it, you can do it graphically, and then it is going to work. But this is not the approach we are going to do right now. Okay, so your CPU is something is going to read everything in the set of what, the set of ones and zeros, like in the terms of zeros and ones. This is how your company is going to, like, sorry, your computer is going to read everything, right? So how this diagram is going to convert it into a form that is readable by the computer. So it is done with the help of the hardware description language. So all this hardware description language, you have, for example, your Verilog, you have your system Verilog, okay, you have your system C. So all these languages are used. So this gap which is there, okay, between this diagram and between the computer. So this is bridged by this hardware description languages. Okay, so this is where it is coming to the picture. Okay, so you need to have a software tool in order to work all these codes, right? So for that, you're going to use this EDA tool. So this EDA tool is going to come into the picture in between. Okay. So you're going to code everything there, and you're going to develop a blocks with IP, all the IP blocks, the VIP blocks. Okay. So this kind of software codes you're going to write with the help of this EDA tools only. Okay. So this is EDA tools, and then you have your service-based companies. Okay, and your service-based company is nothing but where you are going to, where you are going to produce and give the services. So just like in your IT, you have your same categorization in the VLSI also. So we have the product-based company and the service-based company. Okay. So if in a product-based company, you know what it is going to happen. It is going to develop a whole product. Okay. The company is going to produce a whole product starting from the beginning to the end. Okay. They are going to develop their own product and they're going to release it in the market. So this is the product-based company, right? So in your service-based company, it is going to just provide some services. Okay, so the services which here they have paraphrased as skilled manpower. Okay, because some people who are going to work, they are going to provide these services to this wherever it is required. Okay, so even the clients are from outside, or even sometimes to the product based companies themselves. Okay, so even the product based companies themselves, they may expect some little bit of services from the service based company. And to be fair, this is how most of the places, like most of the service based companies, is earning their revenue. Okay, they will expect, these product based companies is going to expect, they will hire some people from the service based company for some temporary period of time on a contract basis. Okay, so they are not like original employees belonging to the product based company, but just like a, we can say like a temporary employee. They are going to work there for some short period of time. They are going to work, they are going to provide the services. Okay, so this is your services based company. And then after that, you have your post silicon validation company. So this type of companies, they are going to do all the validation work. So after the chip have been manufactured, okay, then you need to do the verification. Okay, so after the fabrication, every kind of thing has been done. You need to make sure that the chip is going to be working depending upon the specifications that has been listed on. So everything should be conducted properly from the basic to the end. So every characteristic should be tested, whether it is related to the analog or the digital part or the whatever things is there. It needs to be completely thoroughly checked. Okay, so this is the work of the post silicon validation company. So all these companies are existing right now. So we are just listed out some of the companies that are available. how the chip companies are there, where fabs are there. So every companies are having a interlinked web. Okay, so these are the some of the companies that are available right now, and these companies are also available in India. Okay, so even if it is not directly there, so some of the other services like service based company is going to uh, it will route you to the product based company. Okay, so this is the intellect web that is available in our country. Okay, so these are just the names we have listed it out. We will share this document, so no worries. So this is the ASIC design flow. Okay, so we have seen regarding some of the things from this design flow. For instance, we have seen regarding the how it's starting from the specification. Okay, so broadly, I already told you it is consisting of two types: the front end and the back end. So in the front end, I told you we had the design and the verification. Those kind of things are available in the front end. In the back end, you have the other type of things. Okay, so from floor planning, placement, clock tree synthesis, routing. So these kind of things are available in the back end. Okay, so we are not going to discuss all these things, but it is just a little bit of a glimpse into how the chip is being manufactured. Okay, starting from the starting to the end. Okay, so here mainly where we are going to end means we are going to start from the specification and we are going to end with the verification. Okay, so from specification to RTL verification is the four topics which you are going to like. It's based on design and verification only. Sometimes your job description may even ask you to handle the synthesis and GLS, nothing but the gate level simulation, but for the most part you will do the verification work. So these are the things that we need. Okay, so these are the roles which are available in the VLSI. So we have the design engineer and the verification engineer. This is the most important roles that are available in our country. So uh, the vacancy for these roles is very much huge. Like the demand, I can say the demand for these roles, design and verification, and leave even the design for verification. It is very much large because the work that is done by the verification engineer is very huge. Okay, so for instance, let's say some 10 design engineers are there for a project and they are developing a particular product. For that, if you need to verify it, you need some into 10 number of engineers. Okay, so you need about 100 engineers to verify that thing which was developed by 10 engineers. So where the demand is there, it means in the verification side. Okay, so we have a shortage in that field where we need such a large number of engineers from the verification. Okay, so both in the design and verification, each have their own challenges. Okay, so the work in which you're going to do in both of the fields, it is going to be a little bit of different with each other. Okay, so it will be unique with each other. So you're going to sometimes the verification guy should also know how the design is being done. Okay, so not fully, but up to some extent he needs to know how the design work is done. So he needs to have a little bit of hardware knowledge also. Okay, so coming to our verification kind of thing, you need knowledge regarding both fields. Okay, so you should know regarding, you should be thorough with the software, and also you should be a little bit of have some basic knowledge and some knowledge regarding the hardware also. Okay, so you should be thorough with both of the things. Okay, so it's not like I just know only hardware or I'm just only proficient in software. So is it enough for me? So you can't say like that. Okay, so you need to be thorough with both of the topics. You need to have some basic kind of knowledge in order to break grounds in the VLSI. Okay, so both of the knowledge you need. Okay, so even in the interviews also, they will ask questions from both sides. They will ask first from digital logic design. So digital logic design is everything is related to what from what we have discussed. So everything is hardware, right? So you need the hardware thing. And then all the HDL languages. So from Verilog, system Verilog, those kind of things are totally what software. So you need hardware and software. So you need both of these things in order to get into the field. Okay. So this is regarding the front end. And apart from the backend, there are for the backend there are other roles also. So you have the physical design, you have the physical verification, you have the STA just for the static timing analysis. So all these roles we are not going to concentrate. Okay, but this kind of roles are also available in the industry. Okay, and then you also have in the fabrication related jobs, and then you have also in the analog also you have analog IC engineers. You need some demand for there also. Okay, but the demand where there is most is in the field of design and verification, particularly in the verification. Okay, so all these are the jobs profiles which we have covered. Okay, so currently we have seen all these kind of things. So what are the misconceptions right now? So what challenge, like what are the misconceptions like people have in their minds regarding this VLSI industry? Is that we have this big myth like AI is going to destroy the VLSI industry, but it is not totally true. The reason is because the AI kind of thing, it is based mostly on training the models. Okay, so you're going to feed some information to the black box. So you're going to train the black box, you're going to train the model, and then it is going to give you the results. Okay, so this is how AI is working, right? So if you need to, if you're going to give some task to this AI to work on, you need to supply some information. Okay, so how we can give the information regarding all this your products to this AI tool? So it is almost like you are giving away your trade secrets to AI tool, right? So it is not at all. People are not stupid enough to give their own company trade secrets to some AI tools. Okay, so it is not at all possible. So that is why this AI and machine learning will not destroy the jobs, but it has been updated, like automated to some extent. But for the purpose of verification, if you want to do a verification or if you want to do a design for these two things, you need a manpower. Okay, only the human can do the verification and it can do the design. So for that, it is always and it is mandatorily required for a person to do this job. A machine cannot be replaced in this kind of things. Okay, and also what other kind of things we have is that the recession is permanent. So of course the recession is there, like the recession impacted here in India also regarding the semiconductor industry. It came and people were able to feel the heat because of the recession. It was there because due to recession there were the demand was low, and due to that the supply was also becoming low, and somehow it impacted the ecosystem also, because I have told you this ecosystem is fully connected, right? So everywhere the connection, like since it was interconnected, the pandemic stopped the, this interconnection to happen, because it disrupted the whole chains itself. So what the other countries could do, they cannot say that we are going to develop and sell our own products, right? Because they are dependent, somewhat dependent on the neighboring countries, the neighboring companies. So for that to happen, they need to they need to have this trade chain. Okay, so this pandemic disrupted the whole trade chain itself. So that is why everything got into recession, and the number of demand and the jobs, everything fell low. But it was not permanent, it was just temporary, just like in the IT. So this thing is just like a temporary phase. Okay, so it all went through and now it is back to normal. Okay, and also the thing is the working in the industry is boring and repetitive. It's not at all boring and repetitive, it is very challenging. So, and also the work which you are going to do is very much important and is very high priority work. Okay, and also let me say something as a verification engineer myself. So your verification has a lot of value to it. Okay, so you can't just take things as just like that and do in your own way, and you cannot do it carelessly. Okay, so you need to do it with the utmost precision and with due diligence. Okay, so you need to do it very carefully. So you need to consider every scenarios, and from every particular angles you need to analyze it. Then only you can make it work. Okay, so it has a lot of challenges involved with this, and it is very really interesting for you to do. It is very nice to work in the industry. Okay, so everyone can go into the industry, but you need to work hard for that, and then with sufficient hard work, you can break into the industry. Okay, so BTech guys can go. Okay, so if you have done MTech, then you can get good pay, but this is not the case. Even if you go to BTech also, if you are joining as a BTech graduate with sufficient experience, you can get very good pay. Okay, and even from triple E backgrounds, so whoever has done has a background in the electronics domain, they can join the industry. Okay, so these are some of the misconceptions that we have seen. And then regarding the roadmap, so how we can start the career. Okay, so first things first, I told you you have to be thorough with your electronics basics from your college day itself. Okay, so you have to see how your knowledge with respect to the electronics, and then from the electronics you have to choose a very particular specific domain. So if I'm saying VLSI, it is a very broad thing. Okay, so from the design to the chip distribution, it is a very vast flow. Okay, so all these stages, at these particular stages, a lot of different people are employed, a lot of different domains are employed, so everything is very very vast compared to the IT. So you need to stick into a particular area. So which area I'm very comfortable and which area I'm very passionate about. You have to find that thing first, and then you have to choose that, and you have to work hard in that area. So for instance, I'm not good at front end. I need back end, so I'm not good at coding. If someone says I'm not good at coding, then this person can shift to back end. Okay, so for back end is there is no coding thing involved in there. All right, so you can do the simulation kind of work thing. Okay, so though that thing is not there, but you can in our like in our slides, but physical verification, physical domain, all these kind of things are there. They can go to that field instead of coming to this field. Okay, so you have to build the skills for that. Okay, you have to build the skills, you have to do the necessary projects. So project is very very important. You have to do at least three or four multiple number of projects you have to do. Then only you can come into the industry, because people who will if you are joining even as an entry level position, they will always ask, they will always check which project you have worked on. So even though if your project, even though if you are not doing it for a company, even though you are doing it as a training institute, those projects are very much needed. Okay, they will compulsorily check this projects. So they will check your knowledge. So how much you have grasped the understanding, how much you have grasped the techniques. So all these things they are going to check it. They are going to test it. And then only they are going to take you in. Okay, so you need to do these projects so that you can level up your all the practical skills. Okay, so once after doing all these things, you are going to get with respect to your goal. Okay, so this is the career, this is the roadmap I have told you about. And yeah, at the last, what are the technical skills? Okay, we can see about some of the technical skills which are needed from the verification. Okay, I'm just going to point out, I'm going to specify only the verification, not with respect to the other things. Okay, maybe for design. Okay, so for verification, you need to have Verilog, you need to have learn system Verilog, and you need to learn UVM. So UVM is not a language, but it is a methodology. Okay, so currently all the companies are expecting all these languages for your uh, position to your verification engineer. Okay, how your test bench is developed. Okay, so all these things are coming in your verification point of thing. Okay, so all these things you need to learn it, and then you need to learn about some scripting kind of things. You need to have some basic knowledge on Linux, on those kind of things. Okay, and then you need to have knowledge regarding the basic digital logic design. So, for example, your FSM, and then your pipelining, and then your CDC. Sorry, these things are related to your design field. Okay, so these things are related to your design field, and you also need to have some compulsory basic knowledge on the protocols also. For example, these are all some bus interface protocols. So all these companies which right now are going to take hold of this particular three projects. Okay, and then you need to have the tool knowledge, how to use the tools and those kind of things. all these things you need to know. For instance, we have the Questasim tool, we also have the Cadence tool. So all these tools you need to have some basic knowledge, and at last you have your soft skills. Okay, so you need to be very good at your communication, and most importantly, on top of everything, you should be good at the problem solving. Okay, so you should be very good at problem solving. You should know how to solve the problems. Okay, so if some error is coming, how the bug is coming, so you need to trace where the bug is coming from. You should know debugging. You should be very strong to debug. So in this kind of things, you should be very much proficient. Okay, you should be very skilled in the field of debugging. Okay, so after you have checklisted all these boxes. Okay, so I'm totally ticking all the boxes. I am very good in all these things. Then, voila, you're good for a verification engineer, and then you can join the company, and then you can work on it. Okay, so you can start your career. After starting the career, after some years, you will gain experience, and with that experience, you can get very good money compared to in IT. Even more than the IT, you can get good money, and you can start your you can set your foothold with respect to the VLSI industry. Okay, so these are the things I wanted to share. And also, last but not the least, I will share another one significant difference with respect to this IT and the VLSI. In the IT, as you are gaining experience, as you are gaining more and more experience, this type of experience is not at all valuable to the seniors, those who are working in the companies. The reason is that the things are continually evolving. Okay, it is continuously updated at a rapid pace in the IT. Okay, so if a new guy is coming, they will always give preference to the new guy. Why? Because the new guy can take on the work of two seniors, and he can do it in a much better way than the seniors, because he's fresh, he's very capable, he's very hardworking. So he doesn't have the mental blocks compared to the seniors. So he can do in a very much better and organized way. So he is an asset for the company. So immediately they will fire the senior, because it will it results in much a good decision compared to having those senior in the hand. Okay, so it's a best approach for those who are in the IT industry. But compared to the VLSI domain, here, if a guy is gaining more and more experience, your experience is the number one asset to the company. Okay, so this experience cannot be gained by the freshers easily, because I told you this field is a little bit of interconnected, and it is closed also. Okay, so even though you may get things like one or two in the internet, but you cannot gain everything from the internet. Okay, so everything is closed. So compared to IT, you have a lot of different courses, you have a lot of different places, you have the GitHubs, you have everything to learn. But here in the VLSI, there is a shortage for that. Okay, and even if there is some online repositories where you can learn this information, you still can't learn each and everything. Okay, so it is very completely difficult. So that is why those who are having experience, they are like asset. Okay, and they will also not find this kind of employees. At the same time, these kind of people are not going to retire easily also. Okay, so that is why people there are not enough jobs created in the VLSI industry. Okay, so it is kind of saturated. Okay, so this is the VLSI industry that I've talked about, and so yeah, I think I've completed my presentation. So I'll stop here, I guess.
Thank you so much, sir, for this insightful session. Guys, I know you have so many questions to ask the sir, but before that, I have something exciting to share today. Let me share my screen and then I'll start. Please give me 2 minutes. Is my screen visible? Please respond in the chat.
Yeah, it is visible.
Thank you, sir. So, guys, this is something we have been working on for a long time at Silicon Sandbox. Just a second. So, we're not just about sharing job updates. We really want to bridge the gap between what you learn in college and what the industry expect. And as Sir said, VLSI is not something you get to learn everywhere. And whatever we learn in college is not enough for your placements in the VLSI industry. So, we at Silicon Sandbox are introducing a VLSI design and verification internship on this June. So, our main objective is to help you gain hands-on experience in VLSI design and verification. It's not just theory. You'll be working with industry standard tools, as Sir said, and whatever protocols, what Sir mentioned, the flows, methodologies that are actually used in the industry. Second, one of the biggest advantage is that you'll learn directly from the mentors and industry supervisors. And finally, our bigger mission is to bridge the gap between academics and industry and help you guys get placed in the VLSI companies. And that's exactly what our new course is about. It's our design verification internship program. It's completely online. We've designed it in such a way to give you hands on exposure to all the tools, the methods, and the mindset the industry needs. You'll get trained by professionals who've actually worked in the field, solving real world problems, and you'll pick up practical skills like digital electronics, Verilog, system Verilog, UVM, and more. And the best part, you'll be working on real industry projects and preparing for placements at the same time. Each session will be 1 hour, 5 days a week, so you can easily balance with your classes and other commitments. The registrations are open till 27th May and the programs officially starts on 1st June. Guys, and we all know VLSI training usually comes at a premium and it's way too expensive. Many institutes charge up to 1 lakh for similar programs. Since this is our first launch, we have kept the pricing very affordable without compromising on the quality you get. And we all know we took something very insightful in today's session. So we have two options you can choose from based on your timeline and the current understanding. The first, design and verification course, which is 3 months long, which is priced at 6K, but we for the first launch we've discounted it for 5K. Covers all basics you need to start, and the advanced design verification course, which is 5 months long, includes two live projects with the design verification course, and it is priced at 8499. And honestly, it's not just about the technical learning. We'll also help you with resume building, interview preparation, and give you practical advice to make you placement ready. And if you have any questions, if it's mentioned here, you can just read it out. And if you're interested, you can mail us or scan this code or WhatsApp us, Instagram, DM us. You can reach us out anyway and we'll share you the process. And I know you guys have too many questions to ask. So I'll give back to Sir so that he can carry forward. Thank you, guys.
Hello. Actually, I'm running out of time. But for the time period. If anybody of you have any questions regarding, you know, for regarding the theoretical part, like whatever we have mentioned regarding leave the courses. So apart from the topic, like the topics which I have taught, if there is any doubt or regarding how you can go into the industry and how you can, how to develop your skills. So if you have any doubts regarding that, so you can shoot your questions. Regarding the, regarding the courses, if you have any doubts, you can contact. Okay, you can contact the admin team. They will answer your queries. So you can directly. I think everyone cannot unmute their mic. So,
So what are the tools are we going to use here?
so the tools. So we are
Right.
going to use the Model Sim and Questa Sim.
Okay.
Okay.
Yeah. Okay.
Okay. Fine. I want to pursue
What
masters
about
in manufacturing
protocols,
due
sir?
to the considering placements. Considering placements required, which one is better option? Opting masters in India, studying abroad. Of course, like studying abroad is the better option, and the best thing is like what I have observed is that people will work for some years, not for more years, just for some number of years, and then people will go to the US for masters in VLSI. Okay, particularly in like in the like I've told you, right, in the domain which they are interested. Okay, so that is a very good actually, because people will get placed, like they will get a job in the US itself and they can get very good money. Okay, so this is one thing like I have literally seen and heard everywhere. But currently, due to this Trump administration, I don't know what kind of impact it is going to have. But I think pursuing masters in abroad is the first better option compared to pursuing masters in India. I can't say the same thing for in India, because in India, not every company is going to approach all the companies, like all the colleges, right, for placements. So if it is a tier one, like this is a point, like I've already told, if it is the IITs, it will come directly. Okay, but apart from the IITs and the tier two, and even if it is a tier three, the chance is very less. So that is why. Okay, but regardless, if you are going to do masters, you will get a good pay. Okay, so it will be a little bit of significant more pay compared to those who have just done their BTech. Okay, so if you have done MTech, you will get a little bit of more pay. Okay, I think I have cleared it. And then um the college have taught me all the
So
topics here.
we've
Sir,
Yes,
heard
I
that.
am. Hello?
can you
So
say
we
one at a time, please?
Hello? Sir, am I audible?
Yeah, tell me. Yeah, you can go on.
Sir, sir, I am currently fourth year student, sir. I am interested in the VLSI. Particularly, I
Okay.
am interested in the physical design and the DV, sir. So after this fourth year, I will go for the
I'm
training in
sorry,
Bangalore.
if I heard it correct, you told physical design and
DV, sir, design verification. So
okay. So both.
after the completion of my college, I will go for the Bangalore, sir, for training institute. So choosing the physical design or DV, which will be the good for future, also the more opportunity. So and also I have noticed that many companies were using the AI tool for the physical design, sir. So I want some advice from you.
Okay, sure. Like the thing is, is, uh, yeah. So both is choose anyone. You choose one place and you have to eventually step on to that place. Okay, move. And regardless of much insights into the industry, because the
Sir, your audio is
case
breaking.
is I am belonging to verification, and the verification is breaking.
Yes, sir.
Just a second. I will try to resolve it. So now, okay, now it is fine. Okay. So even for physical design, also you will use the same. Like you need to use a tool to design it and all. Okay, so it is almost like doing.
Sorry, your voice.
Yeah, like I think there is some connection issues. Now is it clear?
Yes, sir.
Okay, fine. So that is what I have told. Okay, so now you get an idea.
Sir, can you repeat again? It is audio is breaking, so that's why you're not. Sir.
Okay, fine. Like the thing is, both is separate. Okay, one is belonging to front end, like DV is related to front end, and physical design is related to back end. Okay, so this is number one. You have to choose anyone. You can't choose both. Okay, so after if you are interested in physical design, go to physical design. If you're interested in verification, go to verification. Okay, so that is the first point I advise you. And for your thing like AI is coming and replacing, uh, I don't have much knowledge regarding physical design because I am in verification. But I have seen physical design engineers do their work. It is also a kind of manual kind of thing. Like there will be tools for that in order to do the simulation and all. So for that, there is the requirement, absolute requirement for manpower. All right. So you can't just simply give the tool. So what the tool is going to design? Okay. So there is some specifications. Okay. There is someone is giving you the requirements. So if you can't simply give instructions to the tool and do it like that. You have to do it manually, right? So every design thing, construction thing, or verification thing, this is general principle. Every design or verification thing, the person should manually check and work on this thing. Okay, the human should do this. Okay, you clear?
Okay. Okay. Okay.
Okay, all right, fine. Okay, I think we are out of time. Uh, Actually, I'm working in Bangalore for analog electronics is not that much needed for DV. I'm just I'll just answer some of the questions. Uh, no, AI is not going to replace DV. Okay, so don't you worry about that. It is not a problem. Um, okay. Um, so okay. I think I will end with this. Uh, Currently working as hardware engineer, is it possible as to get a switch career to be in this industry? Okay, I mean, it depends upon your own context. Like, for instance, I have worked for this many number of years and I don't want to pursue it, then it's up to you. You can stay in the hardware. Or if you think, what do you mean by hardware? What exactly you mean by hardware? So it is asking some additional questions. Okay. So if you are in the telecommunication domain or something like that, or let's say if you are in the production department, so the growth is not that much there. So I have seen some people who are there in production department for a number of years, and then they have shifted to VLSI. Even after 4 or 5 years, after working on this much time, they have coming to this domain. Because they have gained the awareness which was not present before. Okay, so that is that, and
Sir, whether a CGP is important or not, sir?
it's not important, bro. If you have some decent CGPA, that is okay. But apart from that, it is not that much required.
Okay.
So,
So
for
what is
instance,
the
if you have above
main
8 or above 7.5, that itself is more than enough. CGP is not that much important. It is just like a myth, which we are saying. Okay. So, okay then. I think we can end with this. Okay. So, I'm out of time. So regarding all the questions, the training, you can always state your queries to the those who are in the admin team. They are going to answer all your queries. Okay, so we can end with this right now. All right. Okay, guys. Thank you for all your attention. It's good meeting you all. Yeah. Thank you.
Guys, if you have any questions related to the course, you can ask me now. And yes, I'll share the notes for today's session and the courses as well. And today's recording session also, recorded video also will be shared. You can unmute and ask. We'll surely inform you in the channel if we have a physical design course coming up. We have planned the session to start at 6:30 or 7, just like today's session. It will be live classes and the recorded sessions will be sent to you in the mail. Okay, since we have more questions, the unmute option is only allowed for one. You can just ask in the chat, I'll reply. The project will be on DV, and we have to decide it based on the progress you've done in the internship. The course will probably begin from 1st of June and we're finishing the registrations on 27th May. Yes, guys, you can. First year students are also, if you have a basic knowledge, it will be helpful for you guys. It's not that much of a problem. It's an internship, and for 5 months you get it with a project, and for 3 months it is without the project. Basic knowledge of electronics and normal laws is enough. Yes, it is a placement ready course. We'll surely share the PPT once we are done with the session. Yes, we provide the certificate for the internship. And guys, the feedback form is uploaded. You can please fill it. Try contacting the admin team. Reach us out on Instagram if you have any doubts regarding the fee. So I've discussed the fee structure in the PPT, and I'll share the brochure as well in the channel. So make sure you join our channel. So the contacts of the admin team, I'll just share the number and the mail ID. Guys, the time is up, so I'll share the brochure, and if you have any doubts, you can ask. I'll share the details now as well. Guys, sorry for the inconvenience. I had some network issues from my side. And that's the end of today's session. I hope you guys enjoyed it and learned something from it. And please fill out the feedback form without fail. It's really important for us to know what you felt. And that's it for today's session. You can leave now. And if you have any doubts, you can just ask in the chat, or else you can leave. So I see 18 of you here. Guys, if you have any doubts, you can ask in the chat or leave the session. Thank you guys for joining.